So, hello everybody, and good evening, or specifically, it's already midnight here in Sarawak, in Borneo. It's 12:15:27 a.m. here on 27 June 2026, Saturday. Yeah, and don't worry, I'm going to go to church. Pretty much in the morning, so no worries. I can also manage this in the meantime. And yeah, I've already tested all of the sound loop check and whatnot, so there is nothing to worry. Okay, but in the nutshell, what we are going to watch is the Rocket Labs Electron rocket. Yeah, we are going to watch this one where it will carry the Synspective's StriX-8 10 out of 10. It's pretty pun a punny kind of word there. Okay, for this mission, where it's already been delayed like how many months already, but fortunately the StriX-8 mission's going to be the launch of it. And from what I know, will this satellite, it will be going to the 552 kilometers at the of the of the low Earth or orbit altitude. This one will be targeting around the orbital inclination of 42 degrees. And that's basically in the nutshell. And this satellite is obviously a Earth observation satellite, but also, yeah, but mostly Earth observation satellite. This one serves both for the civilian user, and for some could also be potentially be used as well for the national security related of stuff, because it's also served with the government as part of the customer, other than the other commercial and also non-commercial entity as well. This NGO, non-governmental organization. And yeah, this will be launched from the Māhia Spaceport located in New Zealand, which will be in the launch complex 1. We don't know which launch complex specifically, if it's A or the B side. Yeah, and unfortunately, this is pretty much a, what do I call this, a trend around the Rocket Lab, how they operate this day. Not really very transparent this day, a bit hard to find any information, but that's it. And yeah, anyhow, let me introduce myself before we go with some of the lessons, shall we? And yeah, just one filler word. And yeah, goodness, I'm still training myself here, try to talk as best as I can. So let's go. And hello everybody, and welcome. I'm Suguwa, and just in case you and yeah, this is me. I'm sort of back again, but it's not going to be like very serious comeback for now, because I also really need some kind of rest as well. So at some point, probably there's two kind of situation. It's either would be after the Pegasus XL rocket launches. That one is pretty rare. The air launch orbital rocket, okay, which will be carrying the Catalyst Space Technologies Link spacecraft. That one is for the on-orbit rescue mission for NASA's Swift observatory. Okay, that one will be boosting up to the initial orbit of the 600 kilometers, where if it successfully demonstrated, it will be the best. But it can be either that or for the Amazon Leo LA-08, which will mark the final flight ever for the Atlas V 500 series, and the final payload fairing stacking configuration. After that, we will not see it anymore. So yeah, it's going to be a pretty, how do I say, a pretty memories ahead, since since the variant debut flight on more than 20 years ago. But if we count in the years alone, it will be 20 years like that. Yeah. But anyhow, I'm not 100% sure which one which at point I will start going to take a rest. But if I do, I will come up with the just some talk video or podcast, so you can hear it, so you can hear my official declaration that I took some kind of rest. Yeah, I do need it because I'm very tired for now. Tired behind the scene for other things, but otherwise we shall be good. Okay, and just yeah, for today, just like I mentioned earlier on, this will be the launch of the Rocket Lab's Electron rocket that will be carrying the Synspective's StriX-8 satellite for the mission of 10 all of 10, so pretty good. And this one is essentially an Earth observation satellite, which will be targeting the orbit altitude of 552 kilometers with the orbital inclination of 42 degrees. So that's going to be it. And before we finally go for the start, why not we go some a bit for the lessons, shall we? Okay, so this is it. I'm going to talk first about this satellite. This is the StriX satellite overall, and yes, you can actually visit this page. I've already linked it in the description. And yeah, nowadays, unfortunately, Gunter's space page right now already open with the subscription, especially if you want to read unlimited kind of read. But I understood, because even doing this kind of research nowadays and the amounts of rocket launches, it really took a lot of time. So understandably, this is why Gunter already decided to just open up the subscription. I understand it's not a free labor stuff. Even the kind of research I do this day, it's pretty much obscenely a lot that I cannot catch up everything else. And if I manage the page, possibly I will crash pretty hard before I could even make any move. But anyhow, just in case you want to know, this is how the StriX satellite looks like. Okay, as you can see on the right side, or basically just up from my avatar here, you can see that's how the satellite looks like. And this one is the 100 kilograms of the satellites, weigh 50 kilograms lighter than the prototype of the StriX Alpha and Beta A and B there. Okay, which initially 150 kilograms, but they managed to make it compact with only 100 kilograms, removing this excess 50 kilograms. So it's also pretty good. And the satellite itself, it features, as you can see on the patch, features two deployable pens. One side it carries solar cells, another side is for the X-band radar antenna. So you can say it's actually pretty smart in design as well. The X-band radar antenna is basically below that solar cell. You can see there on the right side, even though you cannot see that much, but try imagine that it's actually pretty compact and pretty smart design. Okay, and for the data itself, in terms of the ground resolution, it only can provides around 1 to 3 meters, and apparently it's also a single polarized VV. I'm not 100% sure about this VV stuff here, but what I know is that it can cover a swath with more than 10, at minimum 10 kilometers, at maximum will be 30 kilometers. But I'm not surprised if they even just go with 30 kilometers, even though with the ground resolution much coarser in comparison to just go with 10 kilometers and then able to go with 1 meters. But that's not the point. Yeah, but there is there's some kind of compromise here and there, so that's pretty typical and normal. Okay, and also it has two kinds of observation modes. The first one is the Stripmap, and another one is the sliding spotlight mode. And apparently each satellite, it has an SAR antenna. In case you want to know, SAR, SAR, stands for synthetic aperture radar. That one is literally 5 meters in length, and usually it's going to store at pretty much, how do I say, Just simple word. It's like you're basically just make it, just do like the kind of JWST kind of deployment. You just make that part just, how do I say? It's not flip. It's something like you just store it. Yeah, it's just another word for stored into much smaller, smaller kind of part. Just make it compact, and then later on you will deploy it later. And because of that, it really allows for the affordable deployment of the constellation, which they will target for the 25 satellites in total. And that's basically it. That's the only best information that we know about. Okay. And also the same can be said, thanks to this new space index sort of become my other kinds of alternative stuff if you want to. And for the power amplifiers, apparently they are using 3 kilowatts. Okay, and that's basically it. Also, I'm not going to talk too much here. This is how also the satellites looks like, and then another visual view. That's how I get it, and this is how it's actually stored, and also how do you keep it tidy, neat inside, neat pack inside. Oh yeah, that's the word that I should have used for the stored word. You just pack it inside. Okay, you just make it smaller and smaller, and this is how it looks like. Okay, so that's why I said the design is pretty smart. Okay, and basically that's the ground to cover. I can say, I assume, looking at this. Oh, okay. So this one is another picture, but it's okay. Regardless, this is the batch of this stuff. Okay, Electron rocket. So apparently they are still go. Okay, but we're still not yet listening any kinds of signal. Yeah, even though you can also see from batch I've already given, in case you want to know. And we are still waiting. Well, that's pretty typical. Oh, looks like they have already moved it to 1 a.m. So it's fine. It's okay. Okay, and so far, this is another one. I will refresh this because I really know there must be some kind of other updates. So this is from the NASA Spaceflight Forum, in case you want to know. Okay, here how it should be looking. Okay, another one here, and that's basically it. And the hazard map, especially the launch itself, it should be something like this. The launch side, you can see there. Okay, and if you actually pay attention, if you really notice as well, should be like this one. Let me see. Yeah, I'm trying my best here. Okay, should be good. Okay, so to give you some information, this is the hazard, aka the drop zone, also obtained from the NOTAM notice here. Okay, so this is it. This is the launch site itself, but not specified which one could be the A or B pad. But for one thing's for sure, we know this is the launch complex one, the Rocket Labs launch complex one. Also happens to be I can say the first private orbital rocket launch pad. So that's the information you want to know. This one, I believe, should be the initial flight when it's still going. Anything can happen here. And then this one should be serving for the payload fairing separation on the mark on the red box there. And after that will be the first stage separation on the orange box labeled there, and then it's going to move on until the second stage, or the fully finish its flight. And this is basically how the flights looks like. Okay, so it's not going to pass any points of the Arctic and also the Antarctica, just to give you some information. And yeah, Another one as well. Another one as well. Yeah, just like you can see on the page. Okay. So apparently the reason why they actually delay this stream is it's actually because of the weather condition around the launch complex one. So this is why we have kind of delay, but it's okay. We can still continue. Can shall we? Okay. And in case you want to know about the Electron rocket, especially, just to give you some update, I mean, not give you some update. You by now, some of you already know, but just to give you slide of the update here, I just to give you a bit of quick of update speed here. Electron rocket is the first fully, how do I say, fully electric pump fed rocket engine cycle there. Actually uses on the flight, and it's already proven many times, hundreds of flights, you can say, already have some kind of legacy, and also proving that the flight itself can be done pretty well just on the nothing more than using the battery and connect it with the, if I remember, the DC brush motor, so you can move the propellant to the combustion chamber of the engine itself. And here how's the operation looks like. If you actually make it separate, it can be something like this, but just to give you a bit of the nutshell. Okay, so here is the, okay, so here is the battery pack itself, the vector controller, and then this part is the motor. Yeah, the DC brush motor itself, where it's actually going to force moving this oxygen part. Okay, but in this case it's using the example of the liquid oxygen and also the liquid methane, but however the operation should be quite similar, but we are not, but from my understanding, Rocket Lab, they actually didn't use separate battery pack. It's just that the motor itself literally connects here, and then the battery itself there. If you even see the reason why, just look at this. If you actually look this is what I meant. Okay, you can see on the left side. Okay, this one should be where all of the batteries and the DC brush motor itself actually just move it. And this one, if I remember correctly, is something, it's basically the, how do I say, I really need a very precise word to mention here. This one is just to, yeah, this one is for the vector control. Yeah. So this is what I want to say. This one is just to move that, or just to swing this rocket engine here, for the vector control, and another one swing here, you can see. But if you try to see the kind of rocket engines built in the nutshell for this electric pump fed rocket engines, where it uses the battery, and the battery moves the DC motor brush. Basically, if you see on the typical flight, it's going to use the turbo pump. Yeah, turbo pump, especially with many kinds of rocket engine cycle, like expander cycle, gas generator cycle, and also staged combustion. How do I say? Staged combustion cycle, but not this one. This one is basically just simplifies it. And if there's only one thing that I know very good, what the electric pump fed very good, especially if you have very small rocket, is that you can actually make the rocket propellant much more lighter, because why? Because you don't have to pressurize more of the propellant itself just to move that stuff. So to move it against its will, you just move. All you have to do is just bring that motor brush, let it spins. It's basically functions like turbo pump, but much better. So it can keep it lighter. From my how do I say, from my research, it's basically can it's basic the pressure can be 10 times low or something like that, but it can also be 9, or even only conservative will be 8 times even lower pressure than ever. So you can construct a much lighter rocket tanks, just in the nutshell. And another one as well that I want to show. Okay, and then afterward the operation again, just to move it here. Okay, let's just say, yeah. And then here is the if I remember, the valve here, control valve here, where it's moved. And some parts, it depends, it can be either liquid oxygen, or in this case of this example is the liquid methane. But in our in the cases of the Electron rocket, it uses the rocket propellant 1, RP1, basically a super refined kerosene that contains little to no lead contamination. But in that case, it will, the coolant part will be the liquid oxygen, because, well, liquid, how do I say, well, because the rocket propellant 1, the super refined kerosene, it's not even that cold enough to chill down the rocket engines, even the combustion chamber. So in this case, it will swap the role. Liquid oxygen instead will cool this down. Okay, cool this down surrounding the cooling wall jacket here before it's moving down to the combustion chamber, and the fuel part itself also going to go into the combustion chamber, ignited, and that's how it's basically going to work in the nutshell. Okay, and for that part, usually what you're seeing is basically the bell rocket nozzle there, also known as the D-level nozzle. Originally the usage is for the, if I remember, for moving all of this steam kind of part, super fast steam, how do I say, steam gas or something like that. Yeah, but eventually it found its purpose on rocketry, so, and also aerospace. So eventually this is what the rocket stuff are now adapted to. Okay, and another one, just to give you another better example, much simplified, I can say, is something like this one. Okay, but just replace this liquid methane with the RP1, super refined kerosene, just for a good example. This is how the operation looks like. Okay, the motor and the battery part, and the motor DC brush, it's going to move both of this propellant. Yeah, it's going to move the oxidizer and also the fuel against its typical natural pressurization. Okay, it's just going to be lightly pressure around, just enough to be moved by this DC motor brush, basically replacing the role of the turbo pump. Okay, and then the valve control itself, it's going to move, going to the combustion chamber. Some of it first will go into chilling down, aka cooling down the rocket engines before igniting it, and then going out to the combustion chamber. So that's basically how it works in the nutshell. And this is from the Everyday Astronaut article pages, in case you want to know, but I'm going to highlight the only important part. This is the electric pump fed engine cycle here. So this is actually also how do I understand, just slightly a bit, but very good breakdown if you really want to. Okay, so this is how it looks like. Okay, the pressure will not be very big, just slightly enough just to pressurize it, and then the rest of it will be moved by the DC motor brush as outlined here. Yeah, hello Starship, you're here finally. And unfortunately, looks like the stream is going to be delayed by 35 to 30 minutes, so that's why I can explain a little bit more. So this is how it looks like. Okay, so yeah, finally. And also, I'm briefly back here, but I'm going to take a bit rest after this stream, and then later on will be, hopefully I can cover as well for the Pegasus XL rocket launches. You know, that one is really, you can say, once in a in a lifetime opportunity. It's not launch as much as we want to. So I hope I can cover it when I have time. I hope so before I go taking some break. I mean, I also thinking about taking some break after the Atlas 5 551 rocket launches. That one would be for the final launch of the Amazon Leo LA-08 onboarding the Atlas 5. Okay, but I don't know. Sometimes I feel like maybe I can go without doing that, but well, I don't know. Maybe 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 just for some kind of sanity, maybe I might not cover because because behind the scene I'm a bit busy, with the semester exam and whatnot. But well, I'm here back again. So yeah. So hello, hello Starship. Yeah. So hello. And anyhow, this is basically in the nutshell of the operation I've already mentioned before. And don't worry, you can still look a little bit few minutes ago what I did on the narration stuff. But this is basically replacing the turbo pump part, okay? Where instead the battery connected to the DC motor brush literally will move these propellants together, going inside the combustion chamber. Some of it before that will also be used to cool down the rocket engines, so it can run pretty well. So this is how the electric pump fed rocket engine cycle actually works. And yeah, this is some other kinds of explanation. Like this is actually, for example, how do I get that 10 times of saving? But it can be also a little bit conservative, around maybe even 9, 8, or even 7 times lower pressure. So you can build a much more lighter rocket tank for your rocket itself. Pretty practical for your small orbital rocket, and also for the Sony rocket as well. If you don't prefer using the pressure fed cycle, because pressure fed it's going to add more of that tank mass, and also going to reduce the usable payload that you can aim for. If you don't aim for the orbit, for the suborbital, just going up and then down back again, that's also another uses. So this is for example. Okay, but TLDR it's basically very useful for small rocket, but if you try to make a big one, not really super useful. You still have to rely on much more complicated rocket engine cycle. I mean, especially with all of these turbo turbo pump, yeah, turbo pump components. You have to replace all of these together with the turbo pump, whatever is it, turbo pump impeller, this and that, and then eventually it's going to be very complex, very heavy, and going to be very R&D time and also cost consuming as well. And at that point, you're basically going to have tons of problems. It's basically like, how do I say? Basically, if you can throw lots of time, you might want to pursue with that, because you can also build expander cycle rocket engine. You can also build the gas generator cycle, the open cycle part. Yeah, expander cycle is basically closed cycle, and also the same can be said with the stage combustion cycle. Yeah, stage combustion cycle as well. That's basically it. Okay, and if you want that kind of explanation, maybe you can visit this at some point. Let me see. I hope I can give you this link here. Let me put it on the live chat in case you want to read. Okay, so looks good, but weird. On the top chat, it literally didn't appear, but fortunately I'm using the live chat, so very good. And yeah, another one, just to close in before that, this is the high resolution, the highest part you can see there if you really want to take a look, and that's basically it. Yeah, it's a bit awkward, isn't it? We are still waiting for the live itself. And yeah, there's not much else that I can say because, well, what else you want to know? Maybe other than if I can give you just slightly a little bit more information, it will be something like, let me see here, electron rocket. Yeah, just to fill up sometimes rather than make you a bit of boring here. I might as well just show you how it looks like. Here, something like, oh, wait, tells me I should download that. I don't want to. All I want is just to show you the, oh, maybe there's another better way. Something like this. I don't know. Maybe this is another better one. Okay, so, oh, maybe I should use this in the future. I should use this for my thumbnails because it's actually very rare to see this kind of electron rocket without all of that frostings kind of stuff. If you even see it here, if you see it here, like maybe something like, what's even better? Something like this, I guess. Yeah, like this one, that one, the frosting part there, if you can see from the outside look there, that one is actually caused by the liquid oxygen part, where it's very cold enough, around, if I remember, negative 152 degrees Celsius, so cold that it literally frosts out the tankage part, especially the airframe itself. So that's why it looks like this, but otherwise it's actually pretty normal. Don't worry about that. Yeah. And otherwise, from what you can see, okay, this one is basically a 2-stage rocket, but if you include with the upper stage, technically it's a 3-stage rocket as well. But most of the time, usually Rocket Lab will use the 3-stage part. That one, the 3-stage, if I remember correctly, something to do with either the QE upper stage or the Hyper QE. Hyper QE is basically like the supercharged version of the QE engine. Yeah, QE upper stage engine itself. But otherwise, that's basically it. And in terms of the propellant, it's basically just labeled as the green rocket engine propellant, non-toxic. That's basically the only things that we know, but highly suspected maybe they use their previous technology, the monopropellant rocket patent stuff about the VLS, something like that. Could be they actually use as part of that technology, but well, who knows? We don't know. We might not know that kind of truth. Maybe for another decades or so, before eventually, I don't know what else will happen. And by that point, probably 10 plus years from now, probably the patents will be expired, so anyone can study if they want to about the VLS monopropellant rocket. That's basically in the nutshell what I can gather. So not much else super duper useful, but otherwise other than the upper stage, the rest of the stages, the first stage and the second stage, is the bipropellant rocket. Yeah, the bipropellant liquid fuel rocket. The liquid oxygen part you can see on the top, okay, and on the bottom side, that you don't see any kind of frosting because it doesn't use that kind of, how do I say, the typical sub-chill aka sub-cooled version of the RP1, which will be the super refined kerosene, which will gives around 20-30% more density, something like that. But otherwise that's why you don't see another kinds of frosting usually employed by SpaceX. Usually it would be cooled down around negative 20 plus so degrees Celsius Okay, but otherwise it's not using this flight. It's just basically is what it is. That's how the engine, that's the liquid propellants that we'll be using for today. Yeah, just the normal room temperature rocket propellant for the fuel side. Otherwise, and yeah, the Electron rocket on the first stage it employs nine Rutherford rocket engine. Okay, and on the second stage it only has one Rutherford. That one is basically optimized with the wider, bigger and larger rocket nozzles. That one to ensure that when it ignites in the space environment, especially with almost non-presence of the Earth's atmosphere, it's basically, even though it's still going to expand infinitely as much as the rocket exhaust flame allows to, going going expanding out because of the lacks of the Earth's atmosphere's presence, that pushing it to the wall of the combustion chamber and the rocket nozzle itself. Otherwise, it can enhance and make the thrust efficiency much better than if they not decided to just expand out the, how do I say, not expand out the rocket nozzle. Otherwise, that's basically in the nutshell. And I'm going to show Rutherford engine. Okay, just for your information, this is the sea level employs on the first stage. Otherwise, in case you're very interested, this is the first stage employed. And if we see on the Rutherford vacuum engine, it will be something like this one. Yeah, it will be something. Okay, the best will be something like this. Yeah, the best one will be like this. You can see how we actually supersize the rocket nozzles. There is the difference. Don't you see that? That's basically the difference. It's basically expands that size. Like the expansion factors by how many is it? Yeah, but I'm not going to pretend I know everything about the expansion ratio. I'm still learning at the end of the day, and aerospace engineering is not my it's not my specialty. I'm just some computer science dude anyways. But otherwise that's basically how it works. Like, and also usually on the vacuum engine, because it does not need that much of the thrust in comparison to the sea level. Usually it's going to run with lesser amount of propellant that needs to be consumed in comparison to the sea level. Sometimes it can just only consumes around one digits of kilograms per seconds of fuel in comparison to, say, the sea level on the first stage, like this one, where it can consumes, I don't know, could be something like 4 or 5 times at conservative estimate, but can be 10 times plus more on the maximum side that the propellant can be used and consumed around. So that's basically it. But otherwise, it is basically what it is, and we are still waiting the live stream. And yeah, in the meantime, however, I'm actually just having some kind of fun watching videos here, especially by the Slop's game room. I do actually enjoy watching this kind of stuff, while I'm still waiting. Just to share you a little bit of my interest as well. I don't know. Lately I'm very interested on that kind of stuff. But otherwise, we are still waiting. Yeah, we're still waiting. And there's nothing much else that I want to say. I've already exhausted as much as possible. Oh yeah, and maybe another one. Yeah, another one that I can talk about: liquid oxygen. Yeah, in case you want to know how the liquid oxygen looks like, at best kind of color, it will be something like this, like this one. Okay, you might actually like this a lot. This is basically the best kind of amount of color. it can looks a bit like pale bluish color, okay, or can be a clear liquid color, in case you want to know. And for the RP1 propellant, in case you want to know how it actually looks like, I need something. Mm, okay, but probably the best kind of estimate that I can. Oh, I don't know why sometimes the cloud flare stuff, they can be pretty iffy in terms of kind of uh, bot detection kind of stuff like that. It can be pretty iffy. So I don't know. Maybe the best that I can do like this one, because I want to show you how it actually looks like the RP1. Hmm, what's the best that I can show? Okay, maybe the best will be something like this. I would rather show you this one. Okay, so here how it actually looks like. Okay, so usually this is how the RP1, the rocket propellant one for the fuel, actually looks like. But otherwise, the RP1 is essentially super refined kerosene, and usually the color, u- usually the color, if it's not dyed red here, as you can see, this one is just for the clarity of the view. Usually it can be naturally clear to the pale yellow color otherwise. So this is how it looks like. So thank you to this Wikipedia article and to its user that actually upload this. So it really helps me do some shows you some kind of example how the RP1 rocket propellant one, and apparently also called as the refined petroleum one, okay, super refined kerosene, contains little to no lead contamination. Otherwise, if you use it, it's otherwise if you don't filter out this lead contamination, it yeah, this lead metal, it can damage the rocket engine's operation itself. Yeah, it can corrode any kind of important part, especially right. Imagine this, it actually flowing very very fast, hypersonic speed, pushing out of this exhaust. You don't want this on the rocket engines operation, so this is why very important to have this one. Otherwise, okay, and that's basically it. I've already finished all of my explanation, and I think it's better for us to just wait. Okay, and if there's any kind of stream, yeah, if Rocket Lab finally ready to go and live, you shall be looking at here. In the meantime, however, I think it's better for me to just take a bit of rest. We'll wait for this to go live. So yeah, no problem. If there's anything, I'm going to switch right away. So thank you. We'll be back. It's not going to be that long. We'll see that. Or maybe I can just put it here, I guess. Yeah, I guess here. Okay, so stay tuned. We'll be back in the meantime. Oh, Starship. You're working on a CubeSat IR set? Okay. That's very interesting. That's very interesting. So, hmm, maybe I should look what IR set is all about. Yeah. If you don't mind, I maybe maybe you can share just a little bit something that I don't know, or maybe you know. Yeah, if it's not under NDA. Yeah, imager radiation satellite. Oh, okay. Imager radiation satellite. Let me see. Let me see if there's any kind of if there's any uh information that I can find. IR set. Let me see if there. I hope. I hope. I hope this satellite that you're currently 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 working actually has the database right now. Let me see. Let me see. Am I lucky? Am I lucky, or am I not yet? Hmm, Let me see. Let me see. Let me see. Okay, nanosets database from what I can find. Let me see. Let me see. Oh no! It got delayed again. Oh, oh my goodness! It got delayed again by almost 11 minutes. In case you want to see. Oh no! Oh no! Let me see. Let me see. Oh, it didn't show anything. Oh my goodness. Oh, we should show something. Yeah, in case you want to know. Oh, yeah, you can see more than 10 minutes. It got delayed again. Ah, my goodness. But yeah, otherwise, let me see. Yeah, so far, yeah. So let me see. Can I find information about your satellite kind of job in case if there's any kind of public information out there, or maybe if you can tell us here without being bogged down by the, how do I say, NDAs kind of stuff. If you don't mind, you can tell me, because I'm currently looking just looking around. Let me see. IR set. Okay. So doesn't looks like I have that kind of information, not even on the let me see again. New specs space index. Yes, this is why I'm looking. Let me see. Let me see. Let me see. Is it? Let me see. Okay, constellation. Hmm. Image. Okay. So far I didn't see any kind of database here. So yeah, Starship, looks like you're currently working on this. And I guess this is not yet 100% known, or not yet publicly announced by now. So I say good luck, Starship. I hope you can do your best there. But how do I say, just maybe if you don't mind, I can ask you, if you're not really on the NDA, I mean, how do I say, without literally breaking any kind of NDA kind of stuff that you're currently working, maybe what kind of role that you're actually working on right now on the IR set, aka the imager radiation satellite, and also what kind of probably interesting instruments that you actually take notice so far. Yeah, maybe you can tell us without breaking any kind of NDA, if you can. Maybe even just basic information would have been very good, because I'm very curious. Yeah. Yeah, just as curious as everyone else here. And who knows? I can say, probably, here, viewers, if you, in case you want to know, probably this is the potential kind of site where we got the first information about this stuff. Not yet 100% in the public nanoset database. So yeah, I don't know. Maybe Starship can tell us. Yeah, I don't know. Maybe I indirectly insecure. Indirectly insecure. What I'm talking about? Maybe I indirectly secure some kind of weird live chat interview here. So yeah, maybe you can tell us if it doesn't break any kind of your NDA. You know, your non-disclosure and agreements kind of stuff. If it's okay, if it's not, it's fine. You can just tell us. Maybe slight basic stuff, whatever that doesn't break anything NDA wise, because I understand, it can be kind of anything else. It could have been national security kind of stuff. It could have been something kind of like ITAR, the International Traffic Regulation. And yes, that one is not a joke for your information, viewers. If let's say for whatever reason, if you work on that kind of stuff, you break it. It doesn't matter where country you are. You literally can have some kind of nasty trouble with, especially with the US kind of side. So you don't want to mess up with the ITAR stuff. And also that's also part of the reason why, if you see some kind of project like previously with the Copenhagen suborbiters with their rocket, they kind of topsy with the ITAR regulation. Yeah, especially back then with the now, how do I say, with, if I remember, the one of the important founder is the Christian von Bernstein, something like that. Yeah, and also another one with the Peter Madsen. If you know that guy is pretty, how do I say, I can say pretty colorful history, and also the one with very, how do I say, very sad story behind it. With with the murder of Kim Wall. Yeah, that kind of, how do I say, the journalist that also intends to cover something related with his project back then. But by the time, Peter Madsen no longer with the Copenhagen suborbiters, and they themselves really want to distance themselves from that guy. So by the time actually that incident happens, Copenhagen suborbiters just move on like nothing else happened. And also especially with Chris, how do I even pronounce his name before without even, yeah, without even screwing up his name. Let me see. I need to find it, because later on, this one of the founder itself also founded the also become, how do I say, also become the co-founder of the now defunct Orbex. Yeah, Orbex company, now being folded in, being bought by the Skyrora, if I remember correctly. That now Skyrora basically just buy whatever assets the Orbex literally have, and they never have any kind of orbital flights, unfortunately. Yeah, Christian von Bengtson. Yeah, so this of one of the important person, I can say, eventually establish Orbex. But unfortunately also Orbex never saw any kind of flight, and they gone bankrupt before they even can debut any kind of rocket, especially with the prime orbital rocket. Oh, and also Starship. Oh, no info. Okay, no info. I understood. So basically, NDA is very tight. I believe NDA is very tight. so I understand. So I understand if any kinds of update, no, don't worry. You can just reach out to me if the update, if there's any kind of update yet that you can share. Obviously, without breaking any kind of NDA kind of stuff. I know it's not a joke when you're working with this kind of project. So that's it, folks. That's the only best information that we got. Imager radiation satellite. Oh, and also Imager radiation satellite, because just just from the name itself, I imagine this kind of mission have something to do with the Earth magnetosphere kind of mission. I believe maybe some part of it. This is me just speculate. I know I know Starship cannot even talk about this one, but I speculate this is kind of mission in my mind. Or maybe the second could be something to do with the Earth observation, but something to do with the radiation gravitation stuff. Whatever is it? It's literally just running in my mind right now. Just running very wild in my mind. So, so what is it? What am I even talking about? Yeah. So sorry if I says something sounded like a bit nonsense, but well, but well, I really cannot help. Sometimes I can be a bit weirdly nerdy about this stuff for whatever reason. It is what it is. And now, and you know, the most interesting part is that we are literally just turned this into live, into basically just chatting part. So pretty good, all good. Oh, so yeah, all right, all good. Starship, good luck, with your project, and I'm and I'm keen to and I'm keen to watch out for more info publicly. Yeah, so basically where I'm going to go with the most interesting part. Yeah. Eh. So that's basically, folks. You hear first from Starship. In case you want to know, just head to the live chat, and that's basically it. Just chatting in, and it turns out I do kind of with impromptu live chat interview, but whatever. uh, I just like to think myself a bit like with, how do I say, not investigation part. It's more like the curiosity literally just goes deep right now. So that's why I'm doing this. Very excited right now. Oh yeah. So looks like from what I can look right now, they are targeting the end of window. So so they, oh, we are lucky. Here we go. Let's go. Straight up live right now. And this is it. Let's see what they're going to do next. As soon there's kind of sound, I will I'm going to do some kind of impromptu sound check as well, because some kind of, how do I say, a bit complicated mess with the decibel kind of stuff. You know, I need to check as well from the audio mixer inside the OBS here. Yeah, literally what I'm using right now. And trust me, even though the OBS can be quite complicated at first, but once you know what feature you want to use, surprisingly, it can be pretty intuitive and pretty feature rich, and you shall be able to know which one you will use next. Okay, but otherwise, because of this kind of delay, I guess I need better sleep again. I mean, when after the full satellite deployment, I better go sleep after this one. Yeah, because it's already early morning right now. It's in Borneo. It's 1:17:10 p.m. Sorry, 1:17:15 a.m. here. 27 June 2026. Yeah, we are 8 hours ahead of the universal time coordinate. So, in case you want to know, folks, that's where I am right now. It's basically it is what it is. It's a pretty much early morning here, so I need to go to sleep after that. Oh, Starship! It will go to medium Earth orbit to study Van Allen belts. Oh, Falcon Heavy rocket. Hmm, it's very interesting. That's very interesting. That's very interesting. So, it's pretty close to what I want to say. But yeah, but I forgot. There's also tons of study yeah, need to be made about the Van Allen belts. Yeah, that kind of part. I how, how do I say it? Even the Van Allen belt? Maybe you can correct me. Even then, that one has some kind of layers where you can go and whatnot. And if I remember, Van Allen belts, it's also one of the dangerous zone you can go as well, especially if you want to do some kind of space mission, anything, even for the human mission as well. If you try to go there, basically the amounts of radiation. I mean, I don't have to go too specific, but just imagine it's can be pretty worse. Yeah, it can be pretty worse for you, even if you just briefly goes like what few hours just passing it by. Okay, and anyways, I'm not going to proclaim I know everything about all of this radiation kind of stuff, but imagine this, imagine, Chernobyl, yeah, that kind of fun. So yeah, thank you. So for the Falcon Heavy part, I guess this must okay, maybe I can make some kind of theory. Where's where's your part of your mission will be heading to? Is it have something to do with the Griffin 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 mission, part of that main mission? Could be something to do with the I don't know. Maybe could be something to do. Yeah, could be something to do with the maybe in the future if Blue Origin cannot solve their new Glenn rocket problem, especially with the launchpad. How do I say, sort of like the repairs and reconstruction kind of stuff. Also, oh yes, am I right? The Griffin mission. Oh, looks like I'm. Are you serious? If that's very serious, okay. I hope I can allocate my time to go stream there. If I cannot, it means because well, life literally stares me something. Oh, okay. Yes, but I don't think I can book a flight at the time since I'm in middle school. Yeah, understandable. At the time, it would have been very different time. So all you can do is just all you can do is just work whatever you have right now. Yeah, I understood about that. And yeah, Starship, too many delays, Rocket Lab. Yeah, that's basically what we are dealing with. And also one of the reason why I don't usually if you see on previous routine kind of stuff, usually I don't like going live way too early, exactly for this kind of reason, because of the delay. But I guess maybe this day, if I have to be very honest, I need to be very honest here, folks. Sometimes part of the reasons why I like to go live early as well is that sometimes I I have that kind of stuff that I want people to know my channel actually exists. So if I go early, at least in my part, I'm able to expose my channel to ex how do I say, I can give my channel some exposure because I go live very early. So that's how I do in that's how I actually think. That's why sometimes I go live way early than most of people usually do this day. But yeah, but I don't know. It's not 100%. I want to say I really wanna chess too much about algorithms kind of stuff. Oh, okay. So there's sound. Okay, maybe I'm not going to open the music for now. Yeah, I mean not going to open the that stuff because who knows, could be with potential with the copyright stuff. But you can see very interesting stuff. And also Starship, also ship static fire. Yo, ship static fire. And also, yeah, finally, let's hope they're not going to delay this. If they delay this, dang, I need to put this kind of scrap launch, don't watch kind of notice. And you can see this is how the separation looks like. And when it ignites, well, it's going to blind the sensor. And that's basically how it looks like if it's joined together with the payload adapter and also with the Curie slash Hyper Curie upper stage.
From the east coast of
Oh,
Canada,
yes.
countdown to our next Electron launch from
So,
LC-1.
let's
Bit
see.
of a foggy one today, but there on pad B stands our 91st Electron
Okay,
rocket,
so
ready to carry its
can you
10th
hear
dedicated mission to Leo
properly
for
from
Japan-based
the
Earth observation company
yeah,
Synspective.
Synspective is
We're
from
about 20
it's a
minutes into the
Japanese
countdown to
company in
liftoff,
case you
set
want to know.
today for 5:43 a.m. local time. My name's
Oh,
Julian Spice,
s-
along with Grace and Leslie. We're joining you
and I
from
don't know.
Rocket Lab's Mission Control
I have
Center
I have
here in
some
Paris,
kind of
Brooklyn.
Thanks, Julian. It's been
I
a
have
clear
some kind
run
of
through
hope
the early morning operations, and
that
we're
we
tracking no issues
finally will
across
have
the
our
launch
own
vehicle,
indigenous
Synspective's payload, or the
satellite
range,
and
which sets
also
us up
orbital
nicely for
rocket
an
someday
on-time launch.
and
One
Sony
thing
rocket
we
here in
are
Sarawak
keeping
in
an eye
Borneo.
on
I
is
hope
the
we have
weather,
one
which is a
at
bit
some point.
unsettled and could impact the launch. We'll
But
find
well,
out closer
first step
towards
is first step.
P0. Otherwise, it's onward to
Okay,
launch
T
for
minus
10
20
out of
minutes
10.
and counting for the
We're
launch.
heading to
Yeah, and also Starship
552
Spectrum delayed
kilometer
to
low Earth
July.
orbit today with the score of
Ah,
10 out of 10
I've already
to mark
guessed it.
our 10th
They've already
constellation launch
delayed
for
it to July, so
Synspective
I've
for
already
their
moved
Earth
that
observation
date.
service. With
Not
StriX-8
approximate. I've
delivering
already
their
put it
satellites,
up until
as well
the
as the
end of
geostars,
July.
you can see where the
So
name comes from.
What a hoot.
so
And I mean,
so
the
that
fun
in
opportunities are
case
endless,
they
which
finally
is
set in with the
actually a
date,
good thing
all I just
because
do
we've
is
got another
just
17
change the
Synspective
date,
missions to name after
update the
this one to
thumbnail
fit
to
the
just
owl theme.
match
These
the
missions are
how
to
do I say
establish Synspective's StriX
match the new
constellation
date,
with
and
star
also probably
satellites by the
just
end of this
change
decade. In
the
case you
new
didn't
kinds of
know,
thumbnail that
STAR is a type of
I'm
image
going to
capture
use at
technique
some
which
point
stands for
because
synthetic
yeah, we are
apperture radar.
officially in
This
summer
technology
anyways.
bounces radio waves
And
off of landscapes and objects.
mm, and I can say
Cumulative of
most
those
people,
radio waves
including
are then
myself,
stitched
really
together
hate
to
that kind
create
of
imagery for
weather.
use across industries like urban
Let,
development,
let's
construction
not
and
just say here,
infrastructure monitoring, and disaster
folks,
response.
summer is
Here's more
really
from our
hot
friends at
as hell.
Synspective.
I mean, we already have constant
Synspective's mission is
sunshine as
to
well.
create a new
We know
infrastructure
how
that
hot and
enables the
humid
next
feels
generation
like. Very
to
hot.
understand our Earth
It's not pleasant
scientifically,
here.
quantitatively,
So yeah.
and achieve a resilient future.
And otherwise, here's the view by the Synspective company. The this is the view right now. Okay, so I've already adjusted, and that's it. Very simple. And that's one is another promotional video, or basically company. Okay, you can see this is how this stacking looks like. Hopefully, this is not copyrightable part because for the music part because I don't want this. Also, IR set has 535 lines of code, but I have to get a free ticket for launch or save money. Oh, very interesting. 535 lines of code. That's surprisingly very compact for small satellite, you know. I mean seriously, that's very small. If I can make that kind of coding offline, especially if I decide I want to do that someday, maybe if I decided, hey, I'm going to build satellite stuff, rocket stuff, if getting that kind of amount of lines of code, that one would be very amazing. Will it in theory should be
Alright, I just
able
want
to
to be clear, I
simplify
did not
lots of a
write
job,
these, but we've got a few
especially
owl
with the
puns
technical
that we
stuff.
came up with during
But
that
I
clip if
have
you
to
want to
get a
hear
free
them.
ticket for launch or save money.
Owls gotta let
Yeah.
you go.
So for the
You're
yeah,
all
so
I need.
so good luck.
Owl
I
yo.
hope you can either get anything of
Alright,
these two,
add
but
them to the list, but
getting
maybe
free
don't
ticket
give up your
for
day
launch
job.
I don't think either of us have a career
are
in
much more
comedy
preferable
anytime
because
soon,
you
so I
know
don't really have a
I
problem with
understood
that. Okay,
Not
it's
everyone has
minus
the money.
17 minutes on the clock, and I think
Even
that's a
myself,
great time to
I'm
fill you
kind
in
of
on our
broke
latest
as well.
acquisition here
I
at
can only
Māhia.
afford
We've
mostly
got a
just
robotic
doing this
arm
kind of
slotted
stuff
very
in a
close up to our
virtual view
lineup of
here
hardware and capabilities. This
with the live
technology is
stream
used for
here.
missions
That's
happening
the
at
best thing that
Mars
I can
right
do.
now.
I don't have that
If
kind
you've
of
ever
big
seen
budget money
photos of NASA's
like
Perseverance
Clear
rover
Usui
searching for signs
or
of
even the
past life on
Launchpad
Mars, the technology that makes up that
or
exact
even NASA
robotic arm
spaceflight
is now
or
under
even
the same
spaceflight
roof
now.
here
I
at the
don't
lab.
have that kind of
That
big
makes us
budget
one
like
of only a few
like these people
companies
do.
in the
But
world capable of
don't
delivering
get me
Mars
wrong.
missions
I really
across the
appreciate what
entire spectrum.
they actually
That's
do. They
launch,
already can afford
spacecraft,
it because they
software,
already have
and
that
now
kind of
Mars
audience
proven
before,
robotics for
and this
surface
audience
and on
willing
orbit
to help them.
operations.
With
Here's more
the
about the company and the
with
technology
the
that's joining
and
us
also
here at
combined
the
with
lab.
the donation,
The robotics
merchandising stuff and whatnot.
that we brought on board
They
here are going to
because
enable
of
not
that,
just
they really can raise
missions,
the
but
money
a whole
to
new
do that kind of
diversified
high quality
portfolio of
reporting kind of
components,
stuff and on-site
to,
reporting.
to
Not
proliferate
something
into
that
the
I
space
can
program.
afford to do because, well, too broke, too broke to
From a
even do
big
that.
picture
So
perspective,
maybe the only
robotics
best thing
brings
I can do
into
is
the Rocket
this
Lab
one,
family a number
just
of capabilities that really
passionately talking
solidify
stuff here and there.
vertical
And
integration
this is how
within
it
the
looks
space
like
company.
as well.
Some of those are
You can see
simple,
pretty interesting.
solar array drives and gimbals and things for positioning on orbit.
Yeah.
Others, we move into the optomechanical side with filter wheels and focus mechanisms,
Oh,
also for
oh, photo
imaging
wheel.
Earth and other
Oh, is this
applications like
something
that.
related to do with the
And then finally,
CMOS
the
sensor
robotic
and
side,
also
where we
that kind
can
of
lend a huge
how do I say
support for things like
spectrum
exploration
wavelength kind
robotics,
of
whether that's the moon or
adjustment
Mars,
kind of stuff?
or
I mean,
on-orbit
I try
servicing,
imagine this kind
or
of
even
stuff like the
national
JWST,
security.
one of the component
Bringing these robotics
with the
in-house
spectrometer,
really
something like that.
strengthens our ability to go after these
Yeah,
really complicated
I try to imagine
missions to
that
the
kind of
moon.
stuff.
As we know, there's tremendous excitement and growth in the moon industry right now. Mars is always a very important planet that needs a lot of
I wonder. Oh, is this some?
programs still yet to go.
Is that
And then
part
we think about what's
from the
going
right
on
side
throughout our solar
something to do
system.
related with the
Rocket Lab has always had
possible
a soft
future?
spot for these
How
interplanetary
do I say?
missions,
Mars
whether it's
return
Venus or Mars or the
sampler
moon.
mission there.
We always have an
Yeah,
involvement in them somehow.
but
It's
even
it's
then, it's
core in what we
kinda
do.
in the limbo
And if you think about space,
if that even can
space has
happen.
really been defined over
But we'll
the
see.
last sort of half
Hopefully, it
century
can happen at some
with
point.
robotic missions.
I'm
Obviously, I
excited
come
to
from
know.
a
I mean, I'm
background of doing
excited to
Mars missions,
see
so
in
very
the
excited
future
about
where we are able
Mars
to
sample return and
recover
activities
that
like that,
stuff.
where we can really
Oh,
start
speaking about that one, that lander, it
expand
kind of
on
reminds me
what's
with
been
the
done
Phoenix lander
successfully
as
and
well.
then build a future
Phoenix
there.
lander
This
before,
also a
where
little
it
more
was
permanent.
launched around the
The orbital
2008
side, we have
2009 period,
national security things.
and then it
Obviously,
landed
we're doing a bunch
on
of
one piece with that.
servicing
Yeah, it
activities
reminds me of
for
that
servicing
Phoenix
spacecraft,
lander.
refueling,
That one is
repositioning.
by the
All
NASA,
those things
especially
require robotics,
by the
and that's really starting to ramp up right
none
now.
other but
So
the
almost in
best,
every one of
the
these
god,
areas, we're
greatest
seeing
of
an
all
inflection
time,
point with
JPL,
growth going all
JPL
over the place.
department,
So
the Jet
it's really
Propulsion
exciting
Laboratory
to be
department.
able to have
Also,
Rocket Lab
apparently, also one of the
partner and scale what we're
best
doing
place you
in that
can
area.
you can
We're really
work with.
excited about
Very
the possibility of
good
Rocket
working
Lab
condition
robotics
from
and the scale that
what
we
I
can
know
bring
so
to the
far.
wider
But
organization
yeah,
to it. And I think
that's
this is one of
basically
the
it.
exciting things about when
This
Rocket Lab
animation
acquires a
reminds me of
company is we're able to
Maven
put the
Rip.
full
Yeah,
Rocket Lab
Maven,
universal
the
light into those companies.
We
Mars
have,
volatile.
12 years of building really
Yeah,
advanced
Mars
technology,
volatile
unique in the industry. And
mission like that.
Rocket Lab
Mars
brings
volatile
in a proven
environment
track record
satellite,
of
something like
being
that.
able to
Yeah,
take that and then
yeah,
scale that up.
Rip
That will
Maven.
really
I
enable
last
the
if I
growth of this
remember
site
correctly,
and
last
overall
time
Rocket
Maven
Lab
actually
Robotics brand within
was
the Rocket Lab
operational
family.
around the Mars orbital site. If I remember, Maven last time it operational
It's super exciting
is
to have the Māhia
yeah
team joining
was
us.
operational
With
last
those
time
robotic capabilities on board, we are in a
on
great position to lead on
December
exciting
2025,
major
apparently
missions,
6th December
like bringing
2025.
samples back
And then
from
after that,
Mars,
it no longer
helping build
no
NASA's
longer
Mars
work,
Communications
and the
Network,
and
known as
NASA declared it
MCN,
as
and
no longer
tackling other
functional
important deep
on
space exploration
just
projects
earlier
and
this
national
month, 3
security
June
needs.
So
2026.
cool. Looking
And
at the
speaking about
clock, we're
which,
coming up on the final go no go
also
poll
did
for
you know
today's mission. From
did you know
Navigation
that
Control Center by
this
Launch
year,
Director Michael Pearson, we'll
especially
be
one day
checking in with each one of
after
our
NASA
operators
declared
across the
the
consoles here
Maven
and
as
at the range
lost,
to make sure there are
did you
no
know
critical
that
flags
that's also
preventing us
marked
from moving forward with today's
30
launch?
years
If something
since
does need
the
attention, they'll respond
Ariane
with a
5's
no-go and further
5
info.
inaugural flight,
Otherwise,
which
we're listening
also
out for a clean
unfortunately
sweep
a
of
failed
those from
mission for the
MCC
Ariane 5
starting at
5 1201
minutes on the clock, so let's listen in now.
mission. That one is actually carrying the cluster satellite that's basically studying the Earth's magnetosphere, if I remember, and also the at some point also about the heliophysics mission as well.
Go, no go sequence.
Yeah.
Stage.
And because of that failure, they have to rebuild that cluster satellite again, and it was launched on the Soyuz
GNC is go.
U rocket, if I remember correctly.
Vcon is go.
Okay, and so far this is go, no go poll
GC.
conducted
GC is go.
in case if they are able to go proceed for the launch for today.
RSO.
RSO is go.
Okay, range safety declared okay.
Met is go.
Okay, meteorology is also okay.
MM is go.
I'm not sure.
Fan.
Fan is go.
LSO.
LSO is go.
Launch safety
And
officer.
LD sub.
LD sub is go.
Okay, launch director. Also
KB, go no go sequence is complete.
go
We are
as
T
well.
minus 11 minutes, 11 seconds, and counting. We're go for terminal count auto sequence at T minus 10 minutes. From this time, the 3-word procedure is in effect.
Okay, 60 seconds before Electron rocket will go
That's
into the
exactly what we want to
automated
hear,
launch
Alex NCC.
sequence,
We are go to
which
proceed
basically
towards
means that
Electron's launch at
moving forward,
5:43 a.m.
Electron
local
rocket will
time here in New
will
Zealand,
actually
or 2:43
go in full
a.m. in
control, where it's
Japan
going
for
to
the
do some
Synspective.
kind of
Today's
complicated
mission
checklist
includes
and
rocket
whatnot.
number
Otherwise, it
91.
will
But our
overwhelm
most
the
recent mission on Electron's 90th launch was
something humans
pretty special.
operator. So
About
this
a
is
week
where
ago, we
the
deployed the Victus
the
Haze
the
mission
rocket
for the US
computers
Space
will
Force
on
from
board
this very
will
same
actually
launch site.
start
The mission
taking
was a
over
test to
its
see if we could go
role
from
as well.
call up to
And
launch in a single
of course,
day.
that's also the
If you
period
know
where
anything about
the
Rocket Lab by
rocket
now, you'll know
and
that we
the
took that challenge to
gun
heart
equipment
and
it will
smashed out a new
sync
record in
together
responsive
for the
space time
final
for the DOW.
how do I say for the
16
final
hours and
final
42
launch
minutes. That's all the time it
time
took
as
to
well.
go from phone
So
call to liftoff for
for
Victus
the
Haze.
T minus
Let's
0
take a
after
look
that.
back at the highlights.
Get ready in T minus 5 seconds before auto sequence. T minus 10 minutes mark for the auto sequence to start. Already start by now. Oh yeah, this one, especially the mission, if I remember, this is something to do with the Victor's. If I remember, this is a Victor's Haze Puma mission. Yeah, this one, unfortunately, they did not go live. Yeah, they did not go live stream, so unfortunately we didn't see this. Yeah, you know, right? I mean, for us, we literally just watch this very carefully, especially from the NOTAM, the notice to airmen kind of notice. Most of them speculate how it looks like, but even looking at that trajectory, we just figure out like, this must be that Victor's Haze mission. This must be it, and it is. So basically, because of this kind of launch, this is basically become a national security kind of launch, you know. And you know, especially if you know, if I remember, Russia is actually pretty known for doing this kind of, you know, no live stream kind of any kind of the national security, especially the military kind of satellite launches. So I kind of call it kind of that.
Payload separation confirmed.
Nominal transfer orbit achieved. MD-LD on mission course.
Go ahead,
Yeah.
LD.
Spacecraft separation is confirmed. Victus Haze is all yours.
Copy, LD. Space Systems is taking control. Thanks for the ride.
Oh, okay. Which is, yeah, which is especially if you consider about the US kind of military satellite launch. Usually they will typically go for the
Victus
live
Haze is
stream,
the
but
first launch plus
in
spacecraft
this
mission
case
we've deployed
it's
for
just
the US
basically
Space Force, which is very
operational
exciting stuff.
blackout at that
And
point.
much like how
We
launched
don't
in
even
record
know
time,
up
we
until
completed
the
checkouts for our
final
spacecraft
confirmation
hours
by
ahead of
the
schedule too.
rocket lab
From launch to
themselves.
completed spacecraft commissioning took just 38 hours, more than 33
Okay,
hours ahead of the
38
mission's 72-hour
hours
deadline.
apparently. Yeah.
Check out some of these cool views from LEO from Pioneer's mission assurance cameras. Since then,
Yeah.
Pioneer has completed its
And also
first
it's pretty
rendezvous
surprising,
reverse
usually
mission,
especially for the
which involved getting up
military
close
kind of
and taking
satellite.
images
It's
of a
pretty
second spacecraft.
I'm actually pretty surprised
a bit like a
we
high
even
stakes game
know
of
some
orbital
kind of
cat and mouse.
the shape
Those
shape and
24/7 ops
some
need
kind
to
of view
pioneer
of
and
the
our
satellite
operations
itself. Usually,
suite.
whether
Make
it's
sure to check out
military
our
kind of
website
satellites,
and social
national
pages
security
for more
related
cool photos and
related
videos
satellite,
about the
usually they
missions.
will not disclose how it looks like.
All
But
right, with terminal checks complete
even
and
being able
launch
to
pad
look
ready
at that,
underway, we are
that
at
one
T
is
minus
pretty much
7 minutes and
cake in the
counting.
pie,
Shortly, we'll see
tip top.
the top deck
And
open,
especially if you
and
see on
Stripmap
the
retract in preparation for flight.
launch on the
Now, the
flame
vehicle
trench
taking
there,
Synspective to orbit
you can
today is
see
the
the rocket
Electron
engines
rocket standing
on the first
18
stage.
meters tall on the
The
pad.
9 Merlin.
Electron is a two-stage rocket with a
What?
kick stage
Why am I even saying
dedicated to
Merlin?
launches
Sorry,
for small
I got
satellites
confused with this
across
SpaceX stuff.
commercial, civil, and
The
national
9
security
Rutherford
missions.
rocket engine, that one is the
Coming
sea
in at
level. It's actually
13,000
chilling
kilograms
down.
once
It's
fully
actually
fueled,
cooled down
Electron sits in the
via
small
the
lift class of orbital
liquid
rockets and has
oxygen,
been the
and
world's
also
most
especially
frequently
because
launched
it's
rocket
already
of its type
by now
for
should have
many years
already
now. Today's mission is launch
fully
number 91 for
top up
Electron, and
the
we're
fully
expecting to
loaded
hit launch
with
number
the
100 in the
propellant.
next few months.
100% should be
From
by
the tip
now.
of the rocket,
That's
we
why
have
it
Electron's
that's why
protective
it
fairing
actually
over the top of the StriX satellite
can just
for today's
use, how do I
mission.
say, that's
From this
why
angle, you can see that
they
this
actually
nose cone
able
is
to
not
just
our usual
supply
standard fairing. This one has been
that typical
customized to
liquid oxygen
accommodate
kind
the
of stuff.
boxy
It just
shape of the StriX
put
satellite
all of that
without
excessive
compromising
kind
on
of stuff
aerodynamic
just go
performance. And it's
chill
a
into the
customization we've rolled out for a lot of our
9
Synspective
Rutherford rocket
launches to
engines
date.
there on the first stage.
Once we're in
That one is the
space,
sea
the
level,
fairing's two
where
halves will
it
separate
has
to clear the
shorter
way for the
nozzle.
latest StriX-8 to
Okay,
deliver
shorter
flight.
nozzle, but pretty
We
powerful.
use
It
carbon
consumes
composite material across the
a
fairing
very
and
good
the
tons of
rest
the
of the rocket
propellant.
below it,
Usually
which
operates
is what
around
gives Electron its unique
at least
black
minimum 2
appearance.
digits of the
Carbon composite gives Electron
kilograms
an
per second
exceptional
of
strength to weight
each
ratio
of the
that's strong
propellant
enough to
line,
handle
or
the forces of
when you
launching through
combine all
Earth's
of these together, it's
atmosphere,
going to operate around
whilst
that
keeping
stuff.
the overall
I mean,
structural
try
mass
imagine that
low enough to
only on the
maximize
first,
payload
only
capacity on the
one
solar
of the
rocket.
That's right. Electron's
one of
second
the
and third stages below the
9
fairing
rocket
carry the
engines
same
clustered together.
propulsion
It's
system
already
powered
can
by our
consume how
3D
many
printed Rutherford
already?
engines.
Even
The
if
second
it's
stage
not
contains a
consuming
single
around
Rutherford
tens
engine
of
with a larger
kilograms, just
nozzle
like
made for the
4 or
vacuum of
5
space,
kilograms per
while the
second kind
first
of
stage
stuff,
includes
when you
9 of
combine
those
it
same
together, it's
engines.
a
What
lot,
makes Rutherford
a lot
special
of
is
it.
that it's
That's
the
all.
world's
That's all
first
I'm going to say.
battery-powered 3D printed rocket engine.
And yeah,
It's an electric
it's also a
hot-fed cycle engine that
battery.
uses batteries to power the
Yeah, it's
motors that
also a
drive the
3D
propellant hose.
printed rocket
And
engine.
unlike
In case
open
you want to
cycle
know,
gas generator
can be
engines, which
considered
burn a small
the
amount of
first
propellant to
in
power
the
the
world,
turbo pump,
even at the time
Rutherford
of the
decouples
flight
its pumps
itself.
from the combustion process, which means we don't waste any propellant to run the Rutherford
Yeah, and
propellers at
also very good news
95%
is that this
efficiency.
is considered as the
And because they're
closed
3D
cycle
printed, they're
rocket
relatively
engine
quick to
as
make.
well
It only
for
takes
this
about
electric pump
24
fed.
hours to 3D
But
print the
you
first
need to
chamber.
remember, because
These
they have
chamber
to carry
pumps,
the
new
battery,
propellant valves, and
especially
any other
when you
parts we need
want
for a
to run it
Rutherford engine.
continuously,
In
you need to
fact,
remember
all
the
the
kind
engines
of
on Electron are 3D
energy
printed.
efficiency.
Even the tiny
It's
engine we
not
have on
really
the
the
kick
best
stage.
in comparison to,
That engine is called Curie, and
and
it's
especially the
capable
power
of
density, it's
multiple relights
not the
on
best in
orbit to be
comparison to
able
the
to maneuver the kick
typical
stage for
propellant
plane
lot,
changes,
especially when
altitude
you burn it
adjustments,
together.
or
Because of that,
multi-manifest missions
usually
where
on
we're
the
deploying
second stage,
satellites to
they will
multiple
carry,
locations.
if I remember,
Our
they
capability
carry
is especially useful for
they
constellation deployment
carry a
missions
4
like
battery,
today,
if I remember correctly.
which allow
Yeah,
our
4 battery.
customers to deploy their
2 sets
satellites
of it
exactly where they
are
need to be.
in operational, and after that,
And so
when
for
it
the
conduct
91st
hot
time,
swap,
we are nearly ready to
when
head
the
to orbit
first set
again.
already
That's right,
deplete
we've got
in,
just a
it's
couple of
just
minutes
going
left
to
before liftoff, and soon at the
simultaneously open that
2 minute mark, our operators hand over
the
control to the
second set
rocket's
of it,
flight
another
computer
2
to
half,
take us
and
through to
then
T0.
just
This is called the autonomous auto
and then
sequence
just
start. And from
separates
this point
that
onward,
the
the rocket
depleted
is
battery
essentially
pack
making its
of the
own
first set.
go-no-go decisions
So
based
yeah,
on hundreds of sensor
I
readings
wish we can
across the
see
vehicle.
has hazed
Once it's
payload
one of its
fairing
first
separate
actions is to
on
arm
other live
Electron's
stream. Yeah,
AFTS or
yeah.
autonomous flight
I actually
termination system.
wish we can see it,
It's the
but
system with control over
it is what it
Electron's launch
is.
corridor and
I
with
don't know.
monitoring the rocket's
I don't
trajectory
know,
and flight
Starship.
health for any
It
intervention
is what it is.
needed if things go wrong.
Even I myself
And at the
sometimes
same
can
time, Electron's
can't
propellant
understand
tanks across
why
stage 1
they
and stage 2
don't
are
do
brought
that
up
kind
to
of
their
stuff. But
final flight pressure
well,
levels. That's a call
because
out, and they're within the T minus 1 minute
because
mark.
mostly the haste part,
Pressurization is critical
mostly
because it not only
related
forces
with the
propellant into the Rutherford
national
engine when we move
security
to,
kind of stuff.
but it also provides
Maybe
strength to the tank
maybe
during
also
flight, similar
they
to air
kind of
pressure inside
sign
a balloon.
some kind of the NDA
After
stuff
that, it's on to another 2 call-outs
with the
from the launch
US military
director,
kind
one
of
at
stuff,
T-minus 20
especially with the
seconds and another
US
at
Space Force,
T-minus 10 seconds to mark the
to
final countdown
to
to liftoff.
to just not
These
show
are
any
the
kind of
last
part,
manual
even though
checkpoints
it's
before Electron commits to
quite
flight
weird.
right at
Typically,
T0.
usually on the
Their auto sequence start
US
is
military
moments
kind of
away, so
satellite
we're
launch,
going to hand it over
usually
to mission control
usually
now
they
and
will,
listen in to the final
even
count.
though you don't see
Go
any kind of
Electron,
the
go
payload
Synspective,
kind
and
of
go
shape and
StriX.
whatnot, Usually, typically, sometimes they just going to show you the rocket launches and then after the pellet frame separation, which mostly not all of us going to see. Usually they will just cut it off and then just say, yeah, thank you for watching everybody. Bye bye. And then they just show the replay. Usually that's how it works. But in the recent times I can say it's kinda moving and that
fully on internal power.
it kinda
Case is green and enabled for flight.
okay, it's already gone into the internal power mode right now, which right now the rocket itself, the Electron rocket, right now using its own power, no longer relies on the external electrical ground equipment power there. And by now, getting ready in for the T minus 1 minute, which is 60 seconds.
Box load is complete. System is in recirculation.
Yeah, so yeah, Starship, let's go! And just like your username indicated there, Starship to 1 million, let's go! Let's go, everybody. We will be back. Not, no, why I'm trying to make this kind of commentary like Alien Space, but whatever. It kind of part of my stuff that shapes me early on. T minus 60 seconds, 1 minute, mark. 60 seconds, 1 minute before the flight.
Stage 1 and 2 tanks are pressed for flight.
Yeah, let's go.
High flow
T
engine purge enabled.
Okay. T minus 40 seconds. Hopefully the volume is okay. If it's not okay, please tell me before I screw up everything else. T minus 30 seconds. 29, 28, 27, 26, 25, 24, 23, 22, 21, T minus 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, T minus 10 seconds, 9, 9, 8. Okay, we'll listen in.
5, 4, 3.
Ignition of the Route 9 Rutherford rocket engine on the first stage and liftoff! We have liftoff of the Electron rocket carrying the Synspective's StriX-8 satellite for the 10 out of 10 mission. We have liftoff! And here we go, liftoff! And you can see this is the onboard rocket camera there, I believe attached on the second stage. And you can see the liquid oxygen fluffing there on the tanking. Looks pretty beautiful. And by now, Mach 0.5, which is subsonic by now. By now, it should have already throttled down to 40%, should be, or 60%. Yeah, that one is actually just like the commentator here say, in preparation for the supersonic or supersonic Mach 1, and get ready for the max Q, which is the peak mechanical stress fully induced on the rocket itself as the rockets goes into certain part.
Discharge holding nominal.
Okay, by now okay, already cleared the max Q. That one is pretty important period. If it doesn't pass the max Q, which is the peak mechanical stress induced on the rocket, as a result of the very high speed rocket going on the certain thickness of the atmosphere, if it doesn't pass, the rocket and the satellites will have already self-destruct by that point. But fortunately, it's all good. All is good. And by then, the 9 Rutherford rocket engines should have already throttled up back to 100% or even 80%, depending on the configuration. But by now, you can see the thrust vector control looks pretty good. All is good. And this is where you can see the limitation of the sea level Rutherford rocket engine. As the shorter rocket engine, as the rocket engine is pretty short, it cannot continuously contain that expansion of the rocket exhaust flame there due to the lack of the Earth's atmospheric, or almost lack of the Earth's atmospheric part. So this is where the vacuum Rutherford on the second stage taking part. And this is, you can see, stage separation confirmed. And second stage ignition confirm of the vacuum Rutherford, and
Beautiful
that
execution
and
there
this
by
is
Electron.
what we are
Now
hearing
it's
right
time for
now.
MECO
The
stage sep and nominal
real-time
second stage
onboard
engine start.
microphone
Very soon we're
we
expecting
already pick
fairing
up,
separation
and yeah,
when
just like you
Electron's
said,
nose cone
Miko
splits and
main
pulls
engine cut
away
off,
to
and after
expose
that
the StriX
stage
satellite to
separation, and then
space-to-Earth
followed
for
by
the
the
first time.
second
Let's
engine
watch this together.
start,
You should be able to see the gesture
SCS-1
happen on your screen.
or SCS, and get ready for the pellet fairing to be separated there. And separation confirmed. We have pellet fairing
Fairing job
separation
taking shape,
confirmed
and
for,
you're looking at
and right
Synspective's
now for the
StriX
first
satellite
time
attached there to
the
Electron's kick stage, ascending closer
StriX-8
towards
has
its
already been
operational
are
orbit
now
at
currently being
552
exposed to the space
kilometers above
environment.
Earth.
Believe it or
It's
not, each one of those fairing halves weighs less than 50 kilograms, thanks to its carbon composite construction.
yeah, so
Light enough for
just
a
like
single
we
person
hear,
to move around on
so
their own, though they'd have
in
a bit
total
of
the
difficulty at the speed
pellet
Electron's
fairing
moving right now.
on both
Then,
half is the
8,300 kilometers an
are
hour at
are
climbing
around
more than
100 kilograms,
141 kilometers
okay,
above Earth. The second
or
stage will
almost
continue
like,
on that way for just under
or
6 minutes
basically
longer,
almost
until it's time
200
to separate the
pounds
kick
if you're
stage and
using the
StriX
imperial
satellite into
system.
orbit.
Yeah, so the first, if we only include the first half, it would have been around 50 kilograms or around 100 pounds plus, something like that. So yeah, that's another fun fact that we hear. And just like it says, most of the rocket builds here, it uses the carb carbon fiber kind of stuff. Or basically there is one best.
Stage 2 propulsion holding nominal.
Okay, and also for another best, how do I say, best kind of way to describe it, it's actually what we call as CFRP, carbon fiber reinforced polymer, something like that. Yeah,
T plus 4
for the
minutes, 30
build,
seconds into
just
the
to
mission
make
now,
it
which
good
means we're about halfway through the burn time
and to
of
give it
this
some
Rutherford
additional
engine
strength
on
as well.
Electron's second stage. Because the
And if I
runtime for
remember,
this engine is a
CFRP
lot
also
longer than what it took on the first
kind of
stage.
applied
The
with
batteries
the,
powering the motors that drive Electron's
yeah,
electric pumps
kind
are
of
draining
applied with
close
the
to depletion,
rocket
but we still need batteries to
rocket
keep the
tank
engine running.
tanking
So
build
what we
as
do
well.
next is perform
If you
something
want to
called
keep
the
some kind of
battery hot swap.
rigidity and
We
shape and
essentially
whatnot, you
disconnect
can
and get rid of the
and also
old
to
battery
ensure that
packs that are
the
little
propellant
dead
are
weight for the vehicle, and
compatible with the
connect
rocket
over to a
tank.
fresh battery
Usually
pack
you
that
just
will keep
only
the
apply
engine firing all
the,
the
how
way
do I
through
say,
to our next stage separation event.
yeah, you
It's
just
the
only
silver
apply
battery
the
packs on the
carbon
right that will
fiber
fall
part on
away.
the
So let's keep
outer
a
lining
close eye on the
tank,
screen here
and
to
after
see
that
that
you
moment
just
in real
line it
time.
up with the metal tank, whatever you want to do, even the stainless steel, as long as it can keeps the shape and the propellant tank compatible together. So basically, it's in the category of, if I remember correctly, carbon reinforced, something like that. Yeah,
Ground says
build.
nominal, 200 seconds
And
remaining.
okay, 200 seconds remaining before the battery jettison on the first pack half. That one, this one has 4 battery packs in total, but the first set but each
Throttles down.
set contains two battery packs. So we are going to see the
HVB discharge
two.
holding nominal. Approaching hot swap in roughly 30
Okay,
seconds.
so the first two that's already being expensed will be jettisoned, and the other two will be in use simultaneously for the operation. We will see that jettison will happen soon on the battery part. Okay, and terminal guidance should be already passed by that point. Get ready for the battery jettison on the first set of the used battery pack there. We will see.
Battery jettison
Okay, and battery jettison has already confirmed.
Hot swap successful.
And hot swap has already been done
Hot swap
successfully.
confirmed, and that's a nice continuous burn
Yes,
coming
that's
from the
very
stage
nice.
2 engine
That's
there
what
with
we
that
want to
maneuver
hear so
complete.
far. So
We've got another
good.
3 minutes or so until the second stage's final actions for this mission, which will be to separate the kick stage with its StriX satellite and set it on a course for payload deployment within the hour.
And just to give you some reminder, this kind of mission, it
HVB
needs
discharge
it
holding
actually
nominal.
needs to target around, if I remember, 552 kilometers. Orbital inclination is 42 degrees for this target mission. And you need to remember as well, not only it has to
T
achieve
plus
the
7 minutes and
orbital velocity
17
around
seconds on
more
the
than
clock.
27,000
Electron's second
kilometers
stage
per
is
hour.
firing
Sometimes it can
beautifully
be
as we
slightly lower,
expect. So a
26,000
couple more
plus,
minutes
something
to
like
go
that,
for this phase of the
depending
mission
on
to get
which
the kick
orbit you want to
stage
target,
and
but
StriX
should be
satellite
around that
into position for
part.
payload
Not only it
deployment.
has to achieve
The
that
mission will be
orbital
delivered first to
insertion,
a
orbital
staging
velocity
orbit where
part,
the
but
kick stage
also
will
at the
spend
same
some
time
time
it needs
coasting
to
around Earth
adjust,
before it can align itself on a
how do I say,
circular
adjust
path
the
that
orbital
meets
alignment,
Synspective's
altitude
constellation
part, so
requirements.
it can
Yep, we have a single
properly
engine burn lined up for the kick stage to
circularize
move out of that phasing orbit, which will
or
take
orbiting
place
around the planet.
around
So
40
that's
minutes
basically how
after
it
its
should
separation
work
from the
in
second
a nutshell.
stage.
But however,
After
you can
that,
see
we got a
the
second Curie engine burn to
altitude
line
right
up
now
the
is
payload and release to its exact
257.3 kilometers
552 kilometer target.
altitude and counting
All while
up,
moving at a
and
nominal
the
orbital
velocity right now
velocity
is
somewhere above
20,000, almost
27,000 kilometers an
21,000
hour.
kilometers per
The
hour,
first step before
and
that, of
Mach
course, is the
21,000
final
kilometers per hour,
separation event for this mission.
and counting up
Much like what we
of
did with the
the
first
velocity
stage,
right
we'll
now.
be shutting off the
Okay,
Rutherford
also they
engine with
use
SECO,
the word
the
speed,
second
but
engine
speed
cut
and
off before the
velocity,
kick stage
it
will
has
separate
slightly
from
different
stage 2
meanings,
to
kind
set
of
us off into
stuff,
a
but
staging
for the
orbit
public
for the
facing
mission.
stuff,
SECO
it's
should
sort
be
of
coming up shortly now.
interchangeably
Let's watch
used,
and listen.
so whatever. I don't want to be too picky. I can either say velocity or speed, it should be okay in this kind of stuff. So yeah, for your
System terminal, 20 seconds remaining.
okay, terminal guidance is still in. 20 seconds in before the second engine cut off, SECO, and after that we will see the third engine start number one, or basically not gonna happen. It's going to be after that will be stage separation and
Confirmed.
okay, second engine cut off confirmed,
Stage separation confirmed.
and kick stage separation confirmed on the upper stage.
Beautifully done by the
That one
Rutherford
should be
engine
for
with a
the
nice
Curie
clean
upper stage
shutdown
rocket
on the
engine.
second stage.
We
Off goes
we
the kick
won't know
stage, now
what
on its way to
what it
prepare
actually
for our
powers
10th
it with,
satellite
but
deployment
highly
for the
suspected
Synspective LEO
could be for the
constellation.
from
We
the
got about
previous
40 minutes or so in this
previously
coast phase of the mission
patented
before we come back to the kick stage.
VLS
During this
monopropellant
coast, the kick
previously
stage's flight computer is
when they did it
continuously
back in the
tracking
day.
position and
So
velocity to refine its
especially with
calculations
their
for the
Atia
optimal
sounding
engine
rocket
burn
kind of
needed for
stuff.
its
So could
circularization
be that
and payload
highly
deployment.
suspected, but we
That's
don't know.
coming up at about T plus 53 minutes into flight and should last
Oh,
approximately 2.5
53
minutes. And then
minutes.
within an
Okay.
hour of liftoff,
So
we'll be
we shall
deploying
be
the
back
latest
again
StriX
after
satellite to
that.
orbit. Join us back here soon to see out the final moments of the mission.
Okay, so otherwise we will be back again around 50 plus minutes or so. So yeah, it's really good. Really good time. So if you don't mind, I would like to have some kind of rest after doing this kind of commentary. That don't worry though, I'm not going anywhere. So if you don't see me reply anything inside the live chat, that's basically because I want to get how do I say, I would like to lay a bit in the bed, just a bit before I just go back to this kind of laptop stuff here and doing kind of commentary again. I mean, at the end of the day, I'm 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 sort of like a VTuber here, human at the end of the day. So I do get tired from time to time. So yeah, please understand. We will be back soon. We'll be back around T plus 51 minutes, I guess. 50 minutes, something like that. Yeah. So we shall be back soon. So thank you so much, and please take care of yourself. We'll be back again. Don't worry. I promise I will be back. Okay. So I need to set my timer as well. Will be around half an hour. Yeah. Should be half an hour. Let me see. Let me see. Yeah, half an hour. Yeah, I should do half an hour. So please understand that I do need some kind of rest. Especially what a very chaotic week this week and previous week as well. So yeah, behind the scene, I do take some kind of semester exam stuff here and there before going for another next semester. So yeah, it's understandable. Understandably, I do get tired, and that's why sometimes my update with the video it can be quite scared. But yeah, you got the idea, okay? So that's it. I will be back again soon, everybody. Don't worry, I'm taking my break. So thank you so much. We'll be back soon. Yeah. So if you don't see me on the live chat, that's because of that. And I'm going to write on the live chat in case anyone like, wow, why this dude doesn't reply anything? That's because of that. Yeah. Okay. Okay, so looks like I'm way too early, but it's okay. It's okay. Looks like it. Eh, well, anyhow, this is right now. You can see it's only just around the coastal part area of the Africa right now, and it's going to move forward to the north side there, where it's going to be receive the acquisition signal from the telemetry ground station there. And yeah, we're still waiting in and still waiting, but it's okay. Looks like I need looks like I need to put the rest session again, but it's okay. We are not that long. As long I can get myself preparing and ready, just a bit of warming up before going to live. So why not? It's okay. And we are still waiting. So yeah. Okay, so by now, you have already signal acquisition around the you have already acquisition signal around, yeah, by Spain, especially the Azores island there, and also the mainland Spain, if I remember correctly. Yeah, so correct me if I got it wrong, but that should be it in the nutshell. Yeah, or what? Yeah, whatever. I'm not going to pretend I get this entirely correct, but should be around that part. Should already have signal acquisition, so yeah, we are still waiting in. by now should be less than 5 minutes or less than 5 to 6 minutes before we finally will see the payload deployment for the StriX-8 satellites. Yeah, so we are going to see that soon. Yeah, so I got my geography here correct. Az Azores slash Azores Island. Uh, I mean around the Canary Islands and also the mainland Spain there. Yeah, as you can see, signal acquisitions have already confirmed by now. So yeah. By now, around this point, the the upper stage should have already should have, al- should have already done with the, how do I say, if should have already done with the maneuver to circularize the orbit by opening up by, how do I say, by opening up by starting up its kick kick stage, the upper stage rocket engine of the QV. Okay, and then after the circularization, eventually the engines cut off. That one should last around 1 to 2 minutes, something like that, and after that cut off, and then it's right now in the ballistic course phase flight where no engines are ignited. It's just circling around the earth, and then just waiting for the payload deployment, should be precise around that point. And also, just to give you a little bit of reminder, if you hear something very bad, very rude word behind the scene, it just, if you happen to hear, that's not on me, that's literally on my roommate, and I cannot control it on my side. So please take note. Even though I try to make this channel as, how do I say, as family friendly as possible, yeah, as safe as possible, but unfortunately, in this kind of setting, not really 100% possible, but I've already tried my best using whatever setting that I have with my software, especially with the HyperX Ingenuity software. Yeah, because I'm using the HyperX Solocast 2. Yeah, Solocast 2 mic. So that's what I'm using. I'm basically trying my best just to make sure that my voice is still be able to hear, but the background not much. So that's it. So if you hear some rude word, that's not on me. That's on my roommate. So that's all. Thank you so much. That's all I can do so far. Okay, should be less than 2 minutes, and we shall hear the commentary from the Rocket Lab to be that will be comments and start pretty soon. Well, so get ready, and we'll be ready soon. Okay, commentary should start anytime soon. So let's get ready and listen in. Okay, QV upper stage mission confirmed. That's what I hear. So get ready. Okay, but whatever. We'll still get ready in, so be prepared for any possibility. So yeah. Okay, so I understand why the call out by the mission director. They do.
Stream coverage of the 10 out of 10
Okay,
missions
so that
Synspective
so the
on
reason why
Electron's
the
91st
call out
launch.
is that because
Earlier
after
today,
the
we lifted off the pad
after
right at
the
5:43
ground
a.m. local time
signal
and retrieved
acquisition,
some beautiful
eventually
views of Earth
they
from
were
space
able to
during our nominal
analyze the
flight.
data
If
and
you were listening, you
realize,
might have
yeah,
heard permission
everything
control, Curie confirmation confirmed,
works
which
accordingly
means we're
on
into
the
the
upper
final few
stage
minutes
for the
before we deploy the
QE
10th
upper
StriX
stage already
satellite from
done its job,
Synspective's
and
constellation
all
into
that's
low
left
Earth
is
orbit
the
and carry out its
payload
Earth imaging
payload
operations using
deployment,
synthetic
especially in
aperture
this case will
radar.
be
This
for
is
the
our 10th mission for this customer in a
Synspective's
series of
StriX-8
constellation deployment
SAR
launches lined up
Earth
through to the
observation
end of the
satellite.
decade.
SAR
And
actually
it's an
stands for
exciting moment to see off
synthetic
another Strix bird
aperture
to its new
radar
home in
satellite.
space.
That one is
To get off
for
the
the X-band
elliptical
satellite.
path it
So
was
we
set
will
on,
see
the
that
kick
soon.
stage's Curie
Let's
engine fired up
get ready
just a
in.
few moments ago to set the kick stage on a mostly circular trajectory at 552 kilometers.
Yep,
with a slightly lower perigee at 548 kilometers.
We had a nominal startup of that engine, and we're now just waiting for the Curie shutdown callout to come through. For mission control.
Okay, so 448 kilometers of perigee, so slightly lower, but otherwise still can be raised up to 552 kilometers to properly circularize
Confirmed.
to the orbit. Okay, so Curie upper stage cutoff
Nicely
confirmed.
done from the kick stage and Curie
All
engine.
right,
Confirmation that
nice,
the engine has
nice.
shut down exactly
Great
when we
confirmation
needed
from
to
the
line it up
mission
for payload
director.
deployment in just a few seconds. We got an animation of that sequence to watch.
Get
while we
ready
listen
for
in real
the
time to mission
payload.
control for updates. So
Get
let's
ready for
bring
the
that up now.
payload separation there, which gently will push the satellites from the kick stage and the payload adapter there, where will be gently pushed by the spring loader there, so it can fully properly separate it from the satellite. Get ready and let's listen into the call out by the launch and mission director there. Let's listen in.
Payload separation, StriX-8 confirmed.
Okay, so StriX-8 has already fully confirmed and separated from the
That is 10 out of
from
10
the
for the kick stage and
payload
Synspective
adapter and also
payload
from the
successfully
QE
delivered
upper
to
stage.
orbit as
So the
promised.
mission has already fully confirmed,
Congratulations to the team
fully
and all the best to
successful.
Synspective's operators
So
as
that's
they
very
turn
good.
out,
That's what we
getting
want to
Strix
hear
ready for
so far.
operations as soon as possible.
And all that's left for the QE upper stage, which will be for the orbit, and we enter back to Earth destructively for the mission. So the mission has already done.
And congratulations to the Electron team for their 91st launch to space. Another notch in the belt that gets us closer and closer to our milestone, 100th launch.
So
later this
basically,
year.
we can say
You know, we're gonna have
congratulations
to bring
to
out some
Rocket Lab
special
for
decor
the
for that
successful
one.
launch, and
In the meantime, follow along
congratulations
with Rocket
to
Lab
the
updates and
Synspective
mission
for the
announcements
full
across our social channels
successful
and all
deployment
media
of their
places.
satellite,
We
which
look
right
forward to
now
joining.
right now
We look
become
forward to you
for the
joining us again
total
soon. This
for
is
the
Rocket
launch
Lab
of
Mission
the
Control,
10 of
signing off.
10 satellites overall. So that's basically it. And this is now the view from the Launch Complex 1. I believe this is Launch Complex 1A, if I remember correctly. So I might update this soon. And I will also update from the thumbnail timeline, just in case you want to know. So that's basically it. It's already done, and thank you so much for watching. And Rocket Lab has already concluded their live stream after all of this wait. And yeah, so basically that's it. If you want to have a real-time updates, you can visit their Twitter /X/ yeah, you can go from there using their handle, Rocket Lab. So that's basically it. And that's basically it, everybody. We have already done mission for the launch of the Rocket Lab's Electron rocket carrying the Synspective StriX-8 satellite, as specifically which will be the synthetic aperture radar X-band. Yeah, it's already done, already fully successfully launched. That one is the 100 kilograms of the Earth observation satellite, which actually serves both for the government and also the commercial slash non-governmental organization. It serves for the both of the mission, and it's already done so far. So thank you so much, everybody for watching. And I will also update on the description, or mostly which will be on the how do I say, on the comment section, the launch time and also eventually the pilot separation. So basically it's going to be it. So thank you so much, everybody for watching, and take care. I will also going to take a rest because right now it's almost 2:44 a.m. here, specifically 2:43 a.m. here on 27 June 2026 on Saturday. We are in Sarawak in Borneo. We are 8 hours ahead of the universal time coordinate, so UTC. So you know why it's pretty tiring for me. So otherwise, I would like to take a rest, and thank you so much, everybody, for watching. I'm Dan Suguwa, your host today for today's launch. I've already mentioned before. I don't want to keep mentioning again, or maybe just in case, let me do this in full again for the closing in. I'm Dennis Suguwa, your host today for the Rocket Lab's Electron rocket carrying the Synspective's StriX-8 SAR, the synthetic aperture radar X-band satellite, for basically an Earth observation satellite, successfully launched for this mission. Already done so in very perfect and flawless, magnificent launch of the itself. So thank you so much, everybody for watching. And fortunately, I've already able to done this kind of commentary with less amount of with filter words. So that's pretty good, and this is a very great goal that I have in my mind. So thank you so much, everybody for watching, and take care and stay safe, and see you soon on the next launch, which will be, if I can show you, yeah, I will show for one last time. Here we go. Okay, so for one last time, I will, yeah, I might go with, how do I say, yeah, I might go with this one here. Let me see. Yeah, I will go with this one. So the launch of the SXM 11, this one, if the time doesn't change, yeah, I will try stream this. And at the same time also the next day, which will be the Swift boost mission. Basically, it's essentially a Link spacecraft, basically an on orbit. Not only, it's not really refueling, more like on orbit rescue mission for the Swift space observation satellite for NASA, of course, where they contracted to the Catalyst Space Technologies to do so. And this we will see soon, because this is kind of, how do I say, an even basically a once in a lifetime event. So that's why I would like to stream this as well before I finally go for the break itself as well. So we are going to see that for the Pegasus XL air launch orbital rocket, for the SXM 11 satellite, geostationary satellite for the Sirius XM. This one will be launched on the very iconic, very frequently launched Falcon 9 Block 5 rocket. So that's basically it. Thank you so much, everybody, for watching. I'm Dennis Suguwa, your host today for the launch, and stay safe and take care, everybody, and see you soon. We will be back again. So bye bye, take care, everybody, and yeah. Oh, Yeah. Hello, Ichika. Ichika underscore VT underscore sub. So yeah, your comment is in Japanese, but if yeah, so from your English translation, which I can also hajimemashite, blah, blah, blah. Okay, yeah, nice to meet you. This is my first time seeing this. So yeah, hello, hello, all the way from Japan. Yeah, hello, so nice to meet you. Nice to meet you. Yeah, and I'm glad you actually really can take your time and watch this stream. Yeah, so pretty glad as well. So yeah, unfortunately we are already at the end of this stream. It is what it is, and also because I mean you already know it. In your time right now in Japan, it's already you guys are actually one hours ahead of us here in Borneo. We right now we are in 2:48:20 a.m. here. You guys already 3:48 28 a.m. right now. So you guys already one hours ahead. I know it. It's pretty tiring, isn't it? Waiting for all of these launches. So it is what it is. So thank you so much. We will be back soon, just like I mentioned. But two important events that I would like to cover before I'm not. Yeah. So the first one, which will be SXM 11 for the Series XM. Okay, geostationary. How do I say, more like geostationary communication, radio satellite, something like that. Yeah, it's just to say this one launched on the very vulnerable and very iconic SpaceX's Falcon 9 Block 5 rocket. I don't think I should introduce you anymore. It's already pretty much known. And also for the Swift Boost mission, Link spacecraft specifically, that will be intercepting to the Swift Space Observatory, NASA 1 version, still orbiting. That one, it was launched, if I remember, back in 1995, if I remember correctly. So it's pretty old satellites and still pretty useful for doing any kind of space observation with the astronomy kind of stuff. So they want to boost it up from 400 kilometers, boost it up back to 600 kilometers using this mission. Very high risk, but also high reward mission if everything goes well. Okay, so which will be launched on a very rare but very venerable, pretty much non-rocket here, Pegasus XL, and air launch orbital rocket here. You can say the first ever successfully deployed air launch rocket for the orbital mission. This one is the first one in the history. And then the second one that's successful but unfortunately already mothballed is the Virgin Orbits Launcher 1. That one I can consider it as the first liquid fuel air launch orbital rocket. So yeah, unfortunately, even Richard Branson himself, he doesn't want to bail out that company, so it goes under. Nothing else can be done. So yeah. And also for this one, Amazon Leo LA08, I'm not 100% sure if I can cover this, but if I can, maybe I'll try my luck if I can. But if I don't, it's okay. I can say for my early good farewell, I'll say early farewell to the Atlas 500 series as well rocket, especially the 551. It's a pretty legendary rocket here, pretty beast, very powerful 5 solid rocket boosters attached to the core stage there. So yeah, what a journey, it's been more than 20 years since the first launch of it. That, believe it or not, actually the first launch is for the New Horizon spacecraft that literally goes beyond far to far of our solar system, to the nowadays it's known as the dwarf planet for the Pluto, but back then I remember it used to be called as regular planet. But even then, the IAU kind of decision, the International Astronomical of Union kind of stuff, their decision is kinda controversial to say at least. But I don't know. Maybe in the future they will change their mind about the Pluto's status. But whatever is it, it's also a pretty legendary mission as well. We will see soon. So yeah. And also another one that I will try to remind you as well. I'm not 100% sure whether or not at least there's someone on site, or at least some Korean decided to live stream this launch of the South Korean ADD. ADD stands for Agency for Defense Department, if I remember correctly. Agency for Defense Department, if I remember. That one is the solid fuel space launch vehicle. Basically, this one will be the full stack stages: stage 1, stage 2, stage 3, and also PBS. PBS stands for post boost stage. Nothing to do with the PBS public broadcasting service, even though I like that kind of term as well. But you get the idea. I like to circle back here and there. So basically, we are not pretty sure, but if there's a live stream, I will try. Maybe I should prepare. Yeah, I should prepare the thumbnail just in case we might have any kind of unlikely luck with the live stream. If there is one, I would like to show. But I don't know. I don't know if they will be giving us any precise time. So it is what it is. So yeah. And yeah, I will. Me too. Yeah, so okay, so basically that's it. I'm not going to get too long, otherwise this will be just chatting session, and I really need to have some kind of rest. So thank you so much everybody for watching, and take care, stay safe, and yeah, I'll see you soon on the next stream. Whatever stream is it? It could have been Sirius XM. Sorry, it could have been SXM 11. Could have been Swift Boost mission or / Link spacecraft mission. Could have also been the South Korea ADD's solid fuel SLV space launch vehicle. Who knows? We don't know, but it is what it is. So thank you so much everybody for watching, and I'm also going to put in the comment section each launch separation event, something like that. So yeah, and before I'm fully going to sleep. So thank you so much everybody for watching, and I need to go to church tomorrow morning as well. So well, it is what it is. I want to take a full rest for now. So thank you so much everybody for watching, and take care, stay safe, and bye bye. We will see you soon. Good night everybody. We'll be back again.